Welcome fellow learners. In this video, we are going to build a powerful React agent with memory using Langgraph, and I will show you this step by step in this notebook. So we'll start with a simple React agent, then we will add short-term memory to it, then enable summarization, and finally we will use SQLite database to make it production ready. So by the end of this video, you will learn how to create an intelligent agent which can think, reason and remember just like a human assistant. Alright, so let's begin with a React agent without any memory. Let's first import all the required libraries like LangChain, Langgraph and some tools like Wikipedia Query Run. These are the basic building blocks that we will use to let our agent think and interact with the external data source. So let's run this cell and it will import all the required libraries. Now next, initialize Chat OpenAI model with GPT 4.1 Nano variant. It's lightweight yet powerful model and ideal for fast experimentation. Before running this cell, set your OpenAI API key in your environment variable. So let's run this cell and it will initialize our LLM. So also let's run a simple query to it and see if it is working correctly or not. So let's just run a hi message to it and we will see the result from it. You can see it has provided hello, how can I assist you today? So it's working perfectly fine. Now next we are going to define Wikipedia search tool. So for that part we are going to utilize Wikipedia Query Run module and let's run this cell and it will initialize our Wikipedia. Now next we are going to define a search Wikipedia function. This function takes user's query as an input, searches the Wikipedia and returns the summarized answer. Our agent will use this search Wikipedia function whenever it requires to search for the factual answers from the web, like any events, any word events, any sport event or some history. So let's run this cell to define our search Wikipedia function. Now we bind this Wikipedia tool to our LLM, creating a combined agent that can call external tools during reasoning. Notice that we have set parallel tool calls as false to keep things simple and sequential. So let's run this cell and it will bind our LLM with the tool. Now let's define our agent with the help of Langgraph. We will use state graph to initialize our agent. This is the brain of the Langgraph agent. Then we add nodes for LLM calls, for tool uses and define the flow between them. This call LLM function will be used as node to fetch response from LLM. This graph starts from the call LLM node, moves conditionally to tools if needed and loops back. So let's run this cell and it will define our agent. Now let's see the visual representation of our React graph. Thanks to a Langgraph's mermaid visualization, this makes it super easy to understand how the data flows between nodes. So let's run this cell and you can see the graph in visual way. You can see it start with the call LLM node, loops between tools and then it can provide the final answer with the end node. Now let's test it. We ask a simple query, where will the FIFA World Cup 2026 will be held? The agent will use the Wikipedia tool and returns the answer. So let's run this cell and you can see the FIFA World Cup 2026 query has been passed to Wikipedia and it has successfully fetched the results from the Wikipedia and it has provided the answer like the FIFA World Cup 2026 will be jointly hosted by United States, Canada and Mexico. So this is our first functional React agent. It can think and act but it doesn't remember the past context yet. So let's run the second query. So let's run what are the scheduled dates and let's run this cell. Now let's see what the response will it give. You can see the scheduled date query has been passed to Wikipedia. It has fetched some results from the Wikipedia, but the response are something irrelevant to the past information which we have passed to it. Like we have passed FIFA World Cup 2026 as the previous question and we are asking a question related to that, like what are the scheduled dates for the FIFA World Cup 2026. So this means that since our agent has no memory, it has no idea what we asked before. It treats this as a fresh query, this what are scheduled date, this query, it treats as a fresh query and it gives us unrelated results. That's the limitation of the stateless agent. Now let's give our React agent short-term memory so it can remember what we have asked earlier. We import the in-memory saver from Langgraph and then we pass this saver as a checkpointer while compiling the graph. This ensures the conversation history is preserved across runs. So let's run this cell and it will initialize our memory and then we can pass this memory as a checkpointer while compiling the graph. So let's run this cell and it will create our React agent along with the memory. Now Let's run the same FIFA query sequence again. First we ask where it will be held and then what are the scheduled dates. One more thing over here is that we need to pass a thread ID to it such that it can remember which particular thread it was following and which particular previous context it needs to remember. So let's say there are multiple conversations are happening in the same agent. It will be able to distinguish between those different conversations. So let's run this cell and define the configuration. Now we can pass that config while invoking the message or the query which we are going to pass to the React agent. So let's run the same query. Where will the FIFA World Cup 2026 will be held, and let's see the result. And we can assume that it will give the same result. As we can see here also, it has given the same result. Now let's ask the follow-up question with the same thread ID. It will make sure that our agent remembers the previous query along with the memory that we have passed in checkpointer. So let's run this cell and let's see what result it provides to us. Now this time it has given us the result FIFA World Cup 2026 is scheduled to take place from June 11 to July 19, 2026. So this makes sure that our agent remembers the earlier question and gives a more context-aware answer. That's the beauty of memory in Langgraph. Now a problem arises. If we keep on adding messages to memory, it can grow huge over time. So now we will use LangChain's trim message utility to keep only recent context within a token limit. This will help maintain efficiency while retaining important context. So let's first import few modules. The one is trim messages and the second one is count token approximately. The trim messages module will be used to reduce the size of a chat history to a specific token count or a specified message count. This count token approximately module will be used to count the number of tokens and it will be used in trim messages. So let's run this cell and it will import these two modules. Then we define a pre-hook model to automatically trim messages before each LLM invocation. You can also see that it prints out the trimmed messages for debugging, a great way to see what the model actually receives. So over here you can see I have defined the pre-model hook function, and then in the call LLM node I have used this pre-model hook function before passing the messages to the LLM. So the input state will be passed to this pre-model hook and it will return the trimmed messages, and then only these trimmed messages will be passed to the LLM. So let's run this cell and it will define our pre-model hook and call LLM node. Now we rebuild our state graph with the updated call logic. This time we will include trimming and memory management together. This makes the React agent far more scalable. So over here you can see I am using this call LLM node now, which is calling the pre-model hook inside it, and I am also using memory as a checkpointer while compiling this graph. So let's run this cell and it will create our React agent with the memory and having trimming messages functionality. Now let's test it with a few FIFA queries. You will notice that this time it can handle context gracefully while staying within the context limit. Now over here I have created a config. This time I have passed a different thread ID number 2. So let's run this cell and let's the same queries again. Where will the FIFA World Cup 2026 will be held, and after that what are the scheduled dates. Now you can see firstly in the trimmed messages section over here we are only having this human message, where will the FIFA World Cup 2026 will be held. After that when the query runs, now it has appended the tool call message from the LLM to it. Over here you can see, and after that it has also appended the response from the tool call over here. So this is now the complete trimmed messages. In the pre-model hook we have provided here that max tokens could only be 784. So it will keep on tracking the total count of the tokens, and once it reaches the 784 it will remove the earlier messages. So in the second query, when we ran the second query, you can see it has still the first query in it because the 784 token count has not been exhausted. So over here the first trimmed messages contains these many things. Now you can see in the second trimmed messages where it start over here, it has removed the first query, where will the FIFA World Cup 2026 will happen again. So you can see it is able to trim the messages, and the next time it will only pass that much context to the LLM. Now let's run another query to it. In how many cities will it be hosted? This is one more follow-up query. And now we can see what this trimmed messages is having in it. So you can see it start with what are the scheduled dates, which is the second query. This one, it is not having any information regarding the first one. Where will the FIFA World Cup 2026 will be held? So in this way, we can use trimmed messages functionality with our agent to make sure that our agent can be more scalable and it doesn't run out of the context limit. Now, one more thing is that sometimes we might want to delete the past messages entirely. For example, we want to reset the conversation. Now here you can see that how we can use remove messages class to clear out all the previous context. So let's first import the remove messages from the LangChain core, and after that you can see I have created a function named delete messages. So let's run this cell, and inside this delete messages function you can see I have provided a condition. If the length of messages is greater than 3, it will remove the earliest 2 messages. So the first one is it only removes the 2 messages. The second is we can utilize this remove all messages module from LangChain graph, and then we can utilize this remove all messages while passing the ID to this remove messages function inside the messages, and this will remove all the messages in the previous history. So let's run the second cell also, and then let's see how we can utilize this in our agent. So you can use this delete messages functionality or remove messages functionality inside your call LLM node, and before passing the messages to the LLM, it will delete the number of messages whichever you want. So let's say you want to delete only 2 messages, or you want to delete every single messages from the state, it will delete all those messages. So in this way, we can use this remove messages functionality in our agent to make it more scalable. Now next, we are going to use summarization memory. What will be the benefit of using summarization memory? This allows the agents to compress long conversation into concise summaries, preserving meaning while saving tokens. For this, we are going to use LangMem library. LangMem helps agents learn and adapt from their previous interaction over time. It provides tooling to extract important information from conversation, optimize agent behavior through prompt refinement, and maintain long-term memory. So I have already installed LangMem library. If you haven't, run this cell and install the LangMem library first. Now we are going to use summarize node from the langmem.sortterm for this. So here we are going to import this summarize node first, and then you can see I have created a summarize node. In this I have passed few arguments. One you can see is count token approximately. This will count the tokens. Another is you can see the max token before summary. So it will make sure that before creating the summary of the previous messages, it will see if the count has exceeded the number 256 or not. So let's run this cell, and it will initialize our summarization node. Now we define a new graph where the summarization node feeds summarized context into the LLM. The model can then decide whether to use past information or call the Wikipedia tool again. This design mimics how human recall summarized memories. Now let's create this agent again. So over here you can see I have created the state first. State is using message state. Now I'm using this prompt and passing this to our LLM, this LLM node. Now over here in call LLM node, you can see that I'm extracting summarized messages from the state and passing that summarized messages to the LLM and fetching the information from it. So let's run this cell, and it will define our call LLM node. Now over here you can see I have redefined our graph. So apart from call LLM and tool node, we are also utilizing this summarization node this time. So let's run this cell and visualize how this graph is built. So earlier we were only looping in this tools node. Now what is happening? Firstly, a message will be provided like a user's query, and that will be passed to a summarize node. Then that summarize node will pass that message and create a summary, and then pass that summarized response to our LLM. Then that LLM will call the tool. The response from tool will be again passed to the summarization node, and summarization node will summarize that response from the tools and then pass it to the LLM. This way, it incorporates the summarization node into our React agent. Now let's run our agent again with few examples. It fetches initial information, then continues the conversation intelligently reusing the summaries. So over here you can see I am using a different thread ID this time. Now I'm asking the same query, where will be FIFA World Cup 2026 will be hosted, and passing it to this React graph which we have created over here. So let's run this cell and let's see the results. So it is saying that a prompt is not defined. So I think I forget to run that cell, this prompt. So let's run these cells also, and let's again create our graph. Now we can run these cells, and this time we won't be seeing that error. Now you can see this user's query, and the topic FIFA World Cup 2026 host has been passed to Wikipedia. It fetched the information and the summary was created. So let's see what is the summary it has created. So let's see in the result. Now this result is a dictionary of all the messages that we were seeing in this particular graph invoke. So apart from only messages, you can see there is a summarized messages key in this also, which is having the response from the summarization node. So over here you can see this is a summarized messages which is having this summarized response from the summarization node. So in this way we can utilize this summarization node to make sure that before passing all the messages to the LLM, it firstly summarizes those messages and pass a brief and crisp state to the LLM. So let's run these cells also and let's see which particular summarized messages it is passing to the LLM. So let's print the result again, and we can see the summarized messages key, and let's see what it is having in it. So over here you can see there is summarized messages key, and it is having this summarized response from summarization node. So in this way our React agent is now context aware, efficient and smart. So now we have seen how to use short-term memory, how we can use summarization node. So now how we can make it production ready. So we will do it by replacing in-memory storage with SQLite persistence. This ensures the conversation memory is stored even after restart, perfect for chatbots or assistant deployed at scale. So for that, let's import SQLite 3 and let's create a database. I have created an example database over here and pass that database to our SQLite 3 connection. So let's run this cell and it will create a connection to our SQLite 3 database. So in this way, we can connect to SQLite database and then we can initialize our SQLite saver. So over here, let's run these cells and it will initialize our SQLite saver, and then we can compile the same graph with the persistent backend. So over here, you can see in place of passing short-term memory to our checkpointer while compiling the graph, now I'm passing this persistent memory by using SQLite 3 to this particular React agent while compiling. So I have run this cell and it has initialized our React agent. So now our React agent has true memory across sessions. So let's run it with a different thread ID, and then we can ask few queries that we have asked earlier to it also. And after running these queries, we can inspect the stored messages in the database using getState. So let's run this cell. Then we can ask the same follow-up question, what are the scheduled dates? And then with the help of getState, we can see the complete snapshot of the agent's memory. This is a powerful for debugging or analytics. So let's run this cell and let's see the stored messages. So you can see in this way the messages are stored in our persistent database, in our SQLite database. So all these messages, where will the FIFA World Cup 2026 will be held, response from LLM, that tool call, then response from the tool, then the follow-up question, scheduled dates, and then tool call, then again response from the tool, Wikipedia tool, that everything is being stored in our SQLite database. So now you have it, a complete React agent with memory using Langgraph. We went from simple stateless agent to a fully contextual and persistent one. If you found this helpful, don't forget to like the video, subscribe and drop your questions below. I will be posting more tutorials on advanced LangChain and LangGraph workflows soon. You can also follow the iLearner to be up to date with recent developments in AI field. Thanks for making till the end of this video. Goodbye until the next time.